If you know both the Rham and Cech cohomologies, then now you have too many options. The paradox of choice, now you don't know which one you should use. But the good news is, they are not so different after all. So it turns out, for a Riemann surface, the Rham cohomology groups are just going to be isomorphic to the Cech cohomology groups of the locally constant sheaves. So we're going to prove this in this video, but first let's review the Rham cohomology. So cohomology always comes from a chain complex. Thus to give the Rham cohomology, we'll give the Rham complex. Remember, this means the smooth one form, and these are the smooth two forms. To define a one form or a two form, we only need to give a local expression, because if it extends, then it extends uniquely. And in terms of a local coordinate z, a smooth one form is gonna be a linear combination of these one forms with smooth coefficient. Right, so the first map here sends a smooth function to the following smooth one form. In particular, if f is holomorphic, then this part disappears, and so the image of f is going to be a one form of type 1, 0. Now let's have a look at the second differential. So suppose we have a one form, g dz and h dz bar. So the image is defined to be the sum of two parts, this partial omega, that's defined to be we take the derivative of g and h with respect to z. We take partial dz and then we wedge with here with dz and for h with dz bar. And similarly, partial bar omega is obtained by taking the partial of g and h with z bar. Well, that's what the bar is for, it's for z bar. But now observe that there's the repetition here, so this term vanished. This term is also 0. Thus only these two terms remain. So we want to collect them, and to collect them we just flip these and change the sign, so that every term is in terms of this basis of two form. Alright, so that's the definition of a differential of a one form. And then the Rham cohomology groups are just defined to be the cohomology groups of this chain complex. In particular, what is the zeroth Rham cohomology group of X? It should be the kernel of this D naught, right? So it should consist of all the smooth functions whose image here is 0. So for which smooth function are these going to be 0? Those are going to be exactly the constant function. So we already see that the Rham and the Cech cohomology agree in degree 0. In the next video, we're going to show that they also agree in degree 1 and 2.